Hi, everyone. I am Subhash Guddar. I am the Data Management Practice Lead for Google Cloud in Asia Pacific, and I'm based in Singapore. In my session today, I'm going to walk you through the Google database portfolio, how customers can embark on and progress on their cloud journey with respect to database workloads, and how developers can build next generation innovative applications with Google database services. Given this is a short session, I will not be going into a lot of detail on each individual database, but we will have some follow-on sessions going into some of these database services in some amount of detail as well. So let's get started. Organizations today are building applications for various use cases. Some of these applications support their core business functions. If they are a bank, it could be a core banking system. If they are a web retailer, it could be their web store, which is their core application. It could be a supply chain system for the customer, or it could be a payments gateway if you are in the fintech space. So all of these applications generate a lot of data. That's kind of one kind of application, which are business applications, which a lot of our customers use today. Apart from that, in today's environment, there are applications which also capture a lot of fast-moving data that is coming from devices and machines, as well as activity that we do on websites. So when we go to a web store and we put items in a shopping cart and we remove items from a shopping cart, all those are events which also get captured in a database. All of this data from business applications as well as from external sources is then analyzed by analytical applications which then provide value to the business. When you think of data, when you look at data today, data is considered to be the most critical business asset for any organization. So it's very important that all of this data that the applications are generating and the businesses are using is managed in the right way. So where does all of this data that applications create and use, how does it get handled? And that's really where databases come in. Every application today has some kind of a database that is used to store and manage the data for that particular application. And behind every successful application, there is a great database. So when we talk about databases, what we now need to understand is how do we go about managing this data, given data is considered to be as valuable or even more valuable than oil today. A lot of analysts have talked about data, have equated data to oil, but I think data is even more important than oil. So how do we manage the data and the database infrastructure on which the databases reside? So let's try to understand what do database infrastructures look like today. So if you look at customer environments today, most of the customers, or at least a lot of customers, are running their databases either on-prem, or even if they are running in a public cloud environment, they are running it on compute servers and managing the database environment themselves. So what is the challenge with setting up database infrastructure on-prem or within public cloud environments in a customer managed mode? Setting up a database involves many steps. You need to go and acquire the hardware, servers, and storage. You need to install the operating system. You need to secure the operating system, make sure it is fully secured from any attacks. And then you need to install the database software and also secure the database software as well. Apart from installing the database software, based on your application requirements, you may need to tune the database to meet the performance of your application. And if your database is extremely critical for your business, you also need to worry about how do you make the database highly available. And then at that point of time is when you actually release the database for either developers to use or for businesses to run their application. So as you can see, setting up a database infrastructure involves many steps and has heavy operational toil. The people in your organization, your operations teams, your DBAs, your systems administrators have to spend a lot of time in setting up the database infrastructure, which means that you're taking away the time that developers could have used for building new applications or new capabilities within your applications. So that is a big challenge that we see in existing database infrastructures. Similarly, when the load on your application increases significantly, can your database scale? How quickly can you scale? So, for example, if you're a gaming customer and today you have 10,000 players on your game, and let's say tomorrow morning the 10,000 increases by 10 times to 100,000 customers, 100,000 gamers, will your database be able to keep up? So what we see today is as customers are managing their own database infrastructure, they are spending a lot of time and effort and money to set up the database infrastructure and then to scale it, keep it available, secure it, and so on, which basically means they're not able to spend as much time in innovating for their businesses. So why is that? And what is the problem with these database infrastructures today? One of the biggest problems with traditional databases that a lot of you customers use today is that these databases are monolithic in nature. And scaling these monolithic databases is not easy, right? It can be done, but it's very difficult. And each of these databases has a different way of scaling the database infrastructure. So some databases can be scaled by adding additional nodes, but you need additional licenses for that. Some databases can be scaled by sharding or breaking up the database into multiple pieces. But then the moment you do that, your application then needs to be aware of where your data is located and how to get to the data and so on. So that's kind of one challenge with existing database systems. The second challenge is, as I mentioned earlier, is as your database workload increases, as the number of users on a database increases, if your database infrastructure is not able to keep up with the load on the system, then your database system may crash. And that is a problem for these databases that don't scale well enough. Secondly, if your database infrastructure, whether the database or the operating system on which it runs, has some kind of a security vulnerability, then again, your database infrastructure may be exposed and your database may be taken down by a hacker as well. And finally, as I mentioned in the earlier slide as well, because you need to spend a lot of time in monitoring the database infrastructure, tuning it, creating high availability solutions, and then scaling it on requirements, your operations team ends up spending a lot of effort, which could actually be better spent in creating innovation for your own businesses. So what we really think from a Google perspective is that these existing database systems need to evolve so that the customers can focus more on building applications, on creating value for their organizations, rather than managing the infrastructure. And that's really where an evolution to managed cloud databases is one way for customers to get away from managing the database infrastructure, to get away from monitoring, and then really spending more time on value-added activities like building new capabilities for their users and for their businesses. So cloud databases with the managed capabilities is one way customers can evolve in their database journey. But having said that, we also understand that moving to the cloud in one big motion is not possible for every customer today. Every customer is at a different phase in their cloud journey. Everybody wants to move to the cloud because people understand the benefits that cloud provides to their businesses, but they are not able to move all of their workloads at the same time to the cloud. And that's really where Google's approach really is to meet our customers where they are in their cloud journey, right? So if you look at this picture here, most of our customers really want to get the maximum benefits from the cloud. So they want to be on the right side of this picture, which is really about setting up, building cloud native applications so that they can get the best benefits of the cloud. But again, this can only be done for new applications. If you're building a new application, you can start fresh and you can use the cloud native technologies, both application and database technologies, and start building those new applications. But then every customer has a lot of existing traditional databases as well that they need to worry about and take care of moving to the cloud. And that's where we think that a three-phase journey makes a lot of sense for a customer. So the first phase really is about lifting and shifting your existing workloads to the cloud. And this could be for your traditional databases and traditional applications. So take your existing system as it is and move it to the cloud and get some benefits of moving away from infrastructure management. The second phase could be lifting and modernizing. So you may be running a traditional database and you might want to adopt a more modern open source compatible database. And that could be a journey you could undertake a little while later after you do your migration, a lift and shift to the cloud. And then finally, when you're ready and all of your existing infrastructure is running in the cloud, you can start transforming those databases to cloud-native databases as well. So we really advocate an approach where you can do a phased migration to the cloud. And through the rest of the presentation, we look at some of the options that Google provides to help you to do that, and to developers as well to build new applications. So when we talk about developers building new applications in the cloud, the developer landscape, the data landscape itself has become very complex today. So what we see today in most organizations is that developers and organizations have to deal with multiple types of data sources and data types as well. Data sources could be the standard structured relational data sources that all of us have worked with for many years. These are the relational databases like Oracle or SQL Server or Postgres, which typically are used by a lot of the business applications. But apart from that, over the last few years, we're also seeing data sources in the form of devices, where telemetry data from these devices or from machines running in factories is being captured in real time, so that you can kind of track what is going on, look for defects, and take corrective action based on all of the data coming in. So all of this data is extremely fast moving, and it is not highly structured in nature. There is some structure to this data, but it is not kind of suitable to be stored in a relational database, because relational databases are not very scalable to handle this fast moving data. Similarly, there is unstructured data coming from social media sources as well, like Facebook and Twitter, and so on, where people are making comments on websites, and you need to capture and store that data as well. So all of these data from structured and unstructured sources get stored in a database of some sort. And again, the data types that are used are varied as well. The standard business applications use rows and columns in a relational database, but data coming from other sources could be stored in a JSON format, which is a document style format for storing information. Or customers may want to use applications that capture geolocation data. So having a database that is able to store location information is becoming important today. And of course, graph relationships are important to track relationships between people, relationships between organizations, doing fraud detection, and so on. So the number of data types also has increased significantly. And finally, developers, when they start building applications, they typically like to build applications on a programming language that they're familiar with or that they like. And they choose the programming language that would give them the best development experience. So some developers may want to develop in the Java programming language, others may want to use Python, some others may want to use the Go programming language. And a lot of our customers and developers are refactoring their applications or building new applications using the microservices paradigm. So a data platform should be able to support multiple programming languages as well as the microservices paradigm as well. And all of this, while all of this is being done, the databases and the data platform should have high security, be highly available, and the customers should be able to scale the database based on the workload or the load on the system that keeps on going up and down. And finally, everything should be manageable in a very easy manner. To help our customers provide this choice, to provide our customers a choice of building applications using the programming language of their choice, the data type of their choice, and the source of their choice, Google provides a set of database services that are managed in the GCP environment or the Google Cloud Platform environment. And this slide shows the database services that we offer in the Google Cloud. Some of these database services are created and developed by Google. Some of them are partner services. Let me quickly walk you through each of these in a little bit of detail, but we'll talk about them in more detail as we go along. A lot of our customers today use traditional databases like Oracle to run a lot of their business applications. So to help those customers move their Oracle database workloads to the public cloud, Google provides a solution called the bare metal solution for Oracle, where you can lift and shift your Oracle database workloads and run them in a Google Cloud environment. And I'll explain that how that works in a follow-up slide. Apart from Oracle database workloads, a lot of our customers also use SQL Server or Postgres or MySQL databases, either on-prem or maybe in a different cloud provider as well. And to help those customers gain the benefits of a managed cloud service, Google offers a managed database offering called Cloud SQL, where you can lift and shift your MySQL, PostgreSQL, and SQL Server databases to the Cloud SQL environment on GCP, and you gain the benefits of a managed database service. You don't have to worry about high availability, you don't have to worry about scalability, and so on. And again, I will talk about that. Typically, when a lot of our customers build these database applications, they also need, they have also use cases where they need a sub-second or sub-millisecond response time from their applications. And a lot of our customers use caching services, application tier caching services like Redis and Memcached to accelerate the performance of their database workloads. And that's really where Google provides a managed caching service called Cloud Memory Store, where you can move your Redis and Memcached environments into a managed cloud service in the Google environment with Cloud Memory Store. Right? So these are databases that a lot of our customers use in their existing environment. But as new generation applications came about, developers and customers started using NoSQL key value stores as well as document data stores as well. So Google offers a NoSQL set of databases as well. One of them is called Cloud Bigtable, which is a key value store where you can capture data coming in at a fast rate, right? So high volume, high throughput data with low latency access in a managed cloud service environment is what Cloud Bigtable provides you. So this is a standard key value store that a lot of you are familiar with. A second type of NoSQL database that Google offers in our cloud is also Cloud Firestore, which is more a document style database, and customers and developers use it to build mobile and web applications that can be used in connected and disconnected modes. And I'll talk about this a little more in detail later. So those are kind of the NoSQL databases as well. Apart from that, a lot of our customers are telling us that we really like to build applications and databases using relational technology, but relational databases don't scale well. So we really need something which can scale at a very, very large kind of to handle large volumes of workloads, but still be able to provide the SQL capability, ACID transactions, and so on. And to help those customers, Google offers a very unique database offering called Cloud Spanner, which is a relational database, but that provides non-relational scale. And again, I'll talk about the use cases for Cloud Spanner in a later slide. So these are the Google operational databases that customers can use to build their operational applications for day-to-day use. All of this data that operational databases create can then be analyzed in a database that we call BigQuery, which is Google's data warehouse offering in the cloud, where you can take all of the data from your operational applications, whether it's on Oracle or SQL Server or Postgres or Spanner, and move it to BigQuery and then run your analytical workloads on BigQuery. Apart from these Google database services in the GCP environment, we also support multiple partner databases as well. We know a lot of our customers are choosing third-party databases like MongoDB for JSON-style databases and Neo4j, for example, for graph database applications. And we have managed services in GCP available for customers to use. So what Google Database offers really, or Google Cloud offers really, is a set of database services, both from Google and third-party cloud database vendors, to meet the requirements of all of our customer workloads and our developers as well. Because of all of these different choices and application use cases that Google supports from a database perspective, we have many customers across the world in many industries who have been innovating with Google databases. Some examples are shown in the slide here. I'll talk about 2 or 3 of them. In the retail space, you would have heard of Macy's and Home Depot in the US. They are big users of Google Cloud databases. If you look at the gaming sector, and gaming is one industry which sees rapid scale up and scale down based on a game's success, right? So when you look at customers, gaming companies like Rovio, who built the Angry Birds game, they use Google databases for running their gaming infrastructure. King Games as well, which created Candy Crush, which was wildly popular and had millions of users using the game, also runs on the Google database infrastructure as well. And finally, in the financial services, big banks in the Asia-Pacific region, ANZ Bank, HSBC Bank, and a global payments provider like PayPal also use Google databases to power their business applications as well. And a lot of digital native customers like Gojek, which is something like Uber in the Southeast Asia region, also use Google databases for running their ride-hailing applications as well. Because of this choice that Google provides from a database perspective and the success we've had with our customers, Gartner has also endorsed Google's database strategy. So if you look at the latest Magic Quadrant for cloud database management systems that Gartner released late last year, late 2020, Google has been placed in the leaders quadrant for cloud database management systems. And Google has been placed ahead of Microsoft as well as AWS from a vision perspective, primarily because of the innovative databases that we provide, like Spanner and Bigtable and Firestore, and where we are going with our cloud database environments, and because of the success that we are seeing with customers adopting these databases. So that's really what Google offers to our customers to help them adopt and move their database workloads to the cloud. So once a customer decides that they want to move their database workloads to the cloud, what does the customer data journey look like? And like I said earlier in one of the earlier slides, we advocate a three-phased approach. A migrate, modernize, and transform approach, where you start with the migration journey and lift and shift your workloads to the cloud to get the benefits of infrastructure management. The second phase could be to convert your old traditional databases to more modern, open source compatible databases. And the final journey could be transformation, where you want to provide new customer experiences and build new applications for your users. And that's really where you could use the cloud native databases to build those applications. Again, these three phases do not need to happen one after the other. Based on your timeline, you can start with a lift and shift or a migrate motion and start building new applications with transformative technologies as well. So it's really depends on where you are in your journey and where your developers are comfortable with in building those applications. So let's look at each of these journeys in a little more detail. Let's start with the migration journey, which is really about a homogeneous migration to the Google Cloud environment. And homogeneous migration basically means taking a database and workload and just running it as it is in the public cloud in the GCP environment. I'll talk about two such examples. One is Oracle, and the second one is more open source and SQL Server. So when you look at Oracle database workloads that customers run today, Oracle databases power a lot of the business applications that customers use. It could be a loan management system, it could be an HR system, it could be an ERP system, for example, Oracle E-Business Suite, right? And typically a lot of these Oracle database workloads use some very specific Oracle database capabilities called database options. Examples are if a customer wants a very high availability for their Oracle database, they typically use a feature or option called real application clusters. If they want to compress their data to a very high level, they use an advanced compression option. So a lot of these database workloads use very specific Oracle capabilities that are available on premises. These capabilities are not available for Oracle in a third-party public cloud environment. So if a customer says, I want to run my Oracle database on AWS or Azure, a lot of these options like RAC and Active Data Guard and advanced compression are not available in the third-party databases. But customers would like to use them in the public cloud as well. So to help those customers move their database workloads, Oracle database workloads as is, to the GCP environment, we provide a solution called the bare metal solution, which is a very, very innovative solution. What the bare metal solution provides is industry standard x86 servers and industry standard storage where you can run your Oracle database workloads. And these database servers and storage is installed in a data center that is situated in close proximity or very near to a Google data center. So you have a choice then of running your databases and applications within this data center, or you can run your database in this partner data center and run your application in a Google data center, and both the Google region and the partner data center are connected over a very, very low latency interconnect, which provides less than 2 milliseconds round trip latency. This partner data center is what we call a region extension. And it is a fully, you buy the service from Google and you deploy it in this environment, and you get all of the benefits of all of the Oracle capabilities that you're used to within your on-prem environment. So you have a choice of running your applications, as I said earlier, within the region extension, or you can run your application in the GCP environment on GKE or Cloud Compute Engine and talk to the database running in the region extension. This is a really unique solution for running Oracle databases alongside other Google workloads. So that's an example of how this is a solution that we provide for running Oracle database technologies within the Google environment. A second set of databases that our customers are using are Cloud MySQL, PostgreSQL, and SQL Server as well. And what we offer for customers who want to benefit from a managed database service capability in the cloud is a database service that we call Cloud SQL. And as you can see from this picture here, and compare it to the picture I showed you earlier, what Cloud SQL does is it takes away all of the operational toil. It takes away all of the hard work that you have to do to set up the database environment, to monitor it, to secure it, to scale it up and down, to make it highly available. All of that hard work is managed by the automated service that Google provides as part of the Cloud SQL capability. And all that you need to do as developers is start building applications by spinning up a database instance at the click of a button. All you need to do is go to the Google Cloud Console and spin up an instance in a few minutes, or use an API or Terraform scripts to spin up database instances and start building your application. So you get more time to build your applications and not have to worry about, oh, is my database scalable? How quickly can I scale it up? How do I make my database highly available? So Cloud SQL provides a fully managed database service to run your MySQL, PostgreSQL, and SQL Server workloads in the Google Cloud environment. So the benefits of a Google Cloud SQL, there are 3 or 4 benefits. The first one is that the database services that we support, MySQL, Postgres, and SQL Server, are fully compatible with their open source and SQL Server equivalent. So we do not do any customizations. So developers can be rest assured that they're building against a standard MySQL or PostgreSQL environment. Apart from that, you can connect to these databases using the standard connection drivers, JDBC, etc., as well as use the programming language that you like to use to build those applications. The second benefit really is that this is a fully managed service. So it's extremely simple to use, and you can use either APIs or a Google Cloud Console to start up a database instance, to scale it up, to create a HA instance as you need without having to spend a lot of time on that. And once the database is set up and running, you can monitor it from a developer perspective or a DBA perspective using a capability that we provide called Database Insights, which is a very, very useful capability for developers to see how the database is performing, where their application is not behaving well, and how they can change either the database or the application to get the best performance out of the database. The third benefit really is around performance and scale. Using a set of different storage technologies like hard disks and SSD storage, we provide extremely high performance with Cloud SQL environments. And scaling up the Cloud SQL environment is easy. All you need to do is go to the console or run an API and change the shape on which your Cloud SQL is running on. So if you're running on a 4 CPU machine, you want to make it to an 8 CPU machine, you go into the console and you can scale up the machine based on your requirements. And finally, Cloud SQL is extremely secure because all of the data in Cloud SQL is encrypted both at rest while it is sitting in the database, as well as in transit as it is being read through the network as well. And Cloud SQL also has a set of security certifications like PCI DSS and HIPAA compliance for customers who need those security certifications if they are in a highly regulated industry. And how do you move to Cloud SQL, right? So if you're running on-prem, or if you're running your MySQL or PostgreSQL or SQL Server in a compute engine environment on AWS or even Google Cloud, how do you migrate those databases to Cloud SQL? To help with that, Google has a service called the Database Migration Service that provides you a way to lift and shift your MySQL, PostgreSQL, and SQL Server databases to their Cloud SQL equivalents. What DMS provides is a very simple experience because we provide you a guided navigation path to set up the migration job and then help you validate the job for readiness before you start the migration job. That's one. Second is it's completely serverless. So you do not have to stand up a server. You do not have to install the migration software. You do not have to tune the migration software. Google DMS automatically takes care of all of that for you. And all you need to worry about is just configuring your migration job, and then the GCP DMS service handles the rest. And because we use continuous replication of data from the source to the target environment, your cutover time is extremely low. So your migration can be done with minimal downtime. And finally, because we use the source database's native replication technology, the source and target is extremely compatible, and there is no data loss or no data type loss. So you get high fidelity migrations as you move from your source databases to the Cloud SQL equivalent. And the best part about Cloud DMS or Google DMS is really that it's free. You do not have to pay for this service. It's completely free. You can start up the service and migrate your databases at your own pace. An example of a customer that is using Cloud SQL is Omnio. Omnio is in the retail tech space in Australia, and they create exceptional experiences for their customers in the retail space. And so what Omnio was saying that their customer reach had grown like 10 times. So 10-fold growth in their customers, and they were finding it difficult to deliver up-to-date profile information as well as incentive data to their customers. So Omnio decided to modernize their infrastructure, and they choose GKE or Google Kubernetes Engine for their application tier and Google Cloud SQL for their database tier. They use Cloud SQL to gain valuable insights on customer sentiment and behavior. And after they moved to Cloud SQL, they saw a 40% reduction in hosting costs. Their development time was reduced by 70%, which basically helped them to speed up delivery of new features and enhancements for their customers, which really benefited them by being able to serve a much larger number of customers with a better performance capability as well. So that's really the lift and shift motion of moving your existing databases, whether they're Oracle or SQL Server or MySQL or Postgres, into their managed equivalents on the Google Cloud. The second journey that customers want to do is heterogeneous migrations. And this is really about migrating from traditional databases like Oracle and SQL Server, or even Edge-based, to more modern cloud equivalents or OSS, open source equivalents like Postgres and MySQL or Bigtable from a NoSQL perspective. And to help customers modernize their databases, Google offers a service called the Database Discovery and Assessment Service, where Google engineers come in, work with your teams, and help you discover the various databases that are running in an environment. And then once we discover the databases, we determine what are the target databases that you can migrate to. So there is a discovery phase where we use a tool called Migvisor, which helps us to discover all of the databases and determine which is the best target for migrating to in the Google Cloud. We then look at, using the Migvisor tool, we also determine the migration complexity. Some databases may be more complex to migrate. Some of them may be very easy to migrate. So the Migvisor tool provides you a report which tells you databases A, B, and C are very easy to migrate. You can do it today. Database Y has a high complexity, and you can do that slightly later. Apart from that, we provide a TCO analysis which tells you exactly how much would it cost you to move from your source databases to the target databases that you want to move. And finally, once you determine your target environments, which sources you want to start with, we work with you along with our professional service organizations or your choice of partner to create the migration projects and start on the migration journey. And to help with the migration itself, we provide a set of tools from Google as well as partners that can help you migrate these databases to either the OSS equivalents or to one of the Google databases like Cloud Bigtable or Cloud Spanner. An example of a customer who underwent this journey is McKesson. McKesson is a large pharma provider, primarily based in the US, where they basically work with healthcare providers, pharmacies, and governments to ensure that medical supplies, medicines, etc., are delivered on time where they are needed. Right. So McKesson was running a lot of their operational databases using many databases. They were a big Oracle and SQL Server shop, and a lot of the databases were using those databases. A lot of their applications were using those databases. So what McKesson did is they worked with the Google team, and using the Midvisor utility, they did this entire discovery and assessment phase and analyzed their database workloads. And then they figured out which databases are the easiest to migrate, and then which are medium and high. And then using the tools that are listed on the slide here, some of the GCP tools, some of the open source tools, they migrated to PostgreSQL, Cloud SQL in the Google Cloud. So McKesson got a lot of benefits by moving to OSS database like PostgreSQL by reducing the licensing costs, the support costs that they were paying the traditional database vendors in their environment that they were running on today. So that's really the modernization phase where you can migrate from their traditional databases to OSS compatible databases. The final journey really is transformation, and this is really where a lot of our customers want to get to. And this is really about adopting cloud-native technologies to build new transformative applications. And from a database perspective, I'm going to talk about 3 cloud-native databases today: Cloud Spanner, Cloud Bigtable, and Cloud Memory and Cloud Firestore, and we'll look at that in some more detail. So let's talk about Cloud Spanner first. As I mentioned earlier, a lot of our customers are very, very familiar and comfortable with using relational databases because a lot of the existing databases applications are built on relational technology. But they also want a database that can scale beyond a data center, beyond a region. They want databases that are scalable globally, right? So a relational database today, a traditional relational database, doesn't really scale to a very, very large extent. So what you need to do is you either need to shard your databases and manage the sharding manually, which is, again, a lot of operational work, or you need to end up using NoSQL databases like a key value store to split your database up and then replicate the data. But the moment you do that, you lose the benefits of the SQL language, you lose the benefits of the relational semantics that you're used to. And that's really where Cloud Spanner comes into play. Cloud Spanner is a cloud-native database built by Google, and which is a database that we use internally for a lot of our applications as well, which provide you a database with relational semantics. So you get the SQL programming language, you get ACID transactions, you get schemas, and on top of that, what you get is virtually unlimited scalability. So you can start with a very small Spanner database, let's say running in the Korea region, and then if you want to scale that to, let's say, the US region or Europe or to the other parts of Asia, the same database can be scaled out to any of these regions. So you get virtually unlimited scale by scaling a database up to a large degree. And while you're scaling the database up, the other benefit you get with Spanner is that you get 5 nines of availability, which is 99.999% availability, and you get literally no downtime for maintenance or any other operation. If you want to patch the operating system, patch the database, no downtime. It's a fully managed service. Google takes care of all the management and monitoring for you, and there is no downtime associated with any maintenance activity on the Spanner side. Similarly, if you want to add a new column to a table, you want to drop a column from a table, all of that can be done completely transparently without any downtime. And as the database scales up, the sharding is handled automatically by Spanner, so there is no manual sharding involved, and we manage the replication with strong consistency. So even if a database is spread between Korea, US, and Europe, the replicas that the shards that are stored in the 3 different continents are maintained with strong consistency by the Spanner database. So where is Spanner used today? So there are many use cases for Spanner. Some of them are listed on the slide here. One of the big use cases of Spanner is in the gaming industry. As I said earlier, games are one application that are very, very unpredictable in the number of gamers or users that will use that particular game. right? So a gaming company cannot really predict how successful a game will be, but they need an infrastructure and database and application that is able to scale as gamers start hitting the game and start using the game. And that's really where Spanner comes into play, right? So you can start small, and then as your the number of gamers increase, Spanner can start expanding by adding number of nodes and be able to handle that increased workload that is being thrown by the gamers at that particular application. And you can store various information like game state, player profile information within Spanner. A second example of Spanner could be in the online banking, payments, and ledger applications as well. In the payment space, for example, if you're running a payment gateway, there are millions of users doing transactions with thousands of merchants, right? And all of this data has to be consistent, and the level of transactions is extremely high. And that's really where the scalability of Spanner comes into play, and the strong consistency of Spanner comes into play, because everybody sees the same copy of the data, irrespective of where they access it from, in which part of the world. And because there is absolutely no downtime for maintenance, your payment system never needs to go down while your application is running. So Spanner is extremely useful for applications that need extremely high scale, need the relational semantics, and need extremely high availability. And Spanner provides that with the 5 nines availability that a Spanner has. So that's an extremely useful database for building new experiences for your customers. The second cloud native database I want to talk about is Cloud Bigtable. And this is a key value store database, a NoSQL database that, again, Google uses internally, has been using it for many, many years. And what Cloud Bigtable is good for is really for high throughput, low latency workloads. So if you're capturing data from devices, machines, or even data from website activity or web logs, all of that data can be streamed into Bigtable at a very high velocity, and Bigtable can store that at a very low latency, right at a very low latency. And when you want to read that data back for analysis, you can read that in sub-millisecond latency as well. So really, Bigtable is well suited for databases that need to scale to massive data volumes. You can start from gigabyte scale and go all the way up to petabyte scale databases with Bigtable and get very, very high read and write throughput for unstructured data, because Bigtable is a key value store. Now, when I say key value store, each of the values within every column can also be multi-valued. We store multiple values in a column and give developers a choice of how many values they want to store with different timestamp for each value. So a developer can say that for each column, I want to store 3 values for time 1, time 2, and time 3, and then go and delete the older versions whenever they feel like. In terms of use cases, Bigtable, again, like I said earlier, one big use case is around machine data and IoT information that can be captured and stored and accessed with very, very low latency in Bigtable. It's also very useful for personalization, right? So as users are doing activity on the website, the user profile information can be read with low latency from Bigtable, and you can give them offers saying, oh, you're looking at this handbag, do you also want this other accessory to go along with that, right? So personalization is another big use case that we see our customers using a Bigtable for. And then finally, the third database that I want to talk about is Cloud Firestore, which is really used for building applications for mobile and web use cases. A lot of mobile applications need the ability to have disconnected and connected mode, and developers really want to build these applications extremely fast. So Cloud Firestore provides a rapid application development capability and provides a development toolkit called Firebase, which help developers build applications very fast, and they don't have to worry about how do I synchronize data when the device goes offline and when it comes back online and so on. And if you are accessing the application from multiple devices, Firestore takes care of all of the synchronization of the data across the cloud as well as all of these devices, right? So application development for mobile and web applications is one of the Spanner benefits. ShareChat is an example of a customer who's using a Spanner and Bigtable. ShareChat is a big social media application out of India, and they have 140 million active users, monthly active users that use this application, and their existing database was not scaling well enough for them, and it was getting extremely costly for them to manage this application. They migrated to Spanner and Bigtable. And once they did that, their operating cost reduced by 30%, and they were able to handle a 500% growth in traffic because of their move to Spanner and Bigtable. And they saw a lot of benefits with their move to this application. So to summarize the three journeys, we recommend a migrate, modernize, and transformation phases for customers who want to move to the cloud. But as I said, these don't need to happen in sequence. You can pick and choose the journey that you would like to undertake. So to summarize my presentation, as you adopt the cloud technologies, what Google provides is a set of transformational databases for developers and end users alike, which are very, very simple to use because they're fully self-managed in nature. They're extremely visionary. We have been working with data using a lot of transformational databases inside Google for many years, and we are now making those visionary databases available to our customers for their use cases. And finally, Google databases are completely open. We do not lock you into Google databases. We allow you full portability of data while providing all the innovation from a Google perspective. So that's really what I wanted to cover today. I hope the session was useful to you, and thank you for listening to me, and have a good day.